Science is all around us. Just about every activity we do can be broken down into some type of scientific equation, and cooking is no different. Your kitchen is a laboratory, and every time you make dinner, you are conducting a scientific experiment. Here, every ingredient is a component, and every recipe is a chemical equation for a delicious way to learn about the science of cooking. In the first law of thermodynamics, energy can neither be created nor destroyed. It can, however, change from one form to another. This is also known as conservation of energy. These are some examples.
Yeah, I've worked with them before, in Miami, Orlando. They're a great group of guys. They're always trying to butter me up.
Okay, listen up. Let's see, Chef Paula's taping a segment on salsa next, and she wants you in it. Are you ready?
Oh yeah, I'm fresh from Florida.
Follow me.
What do we got, Detective?
The chef was making a video about making salsa, and she wanted me to be in it. I thought she was talking about the video. She was talking about the salsa.
Here's their artist sketch rendering. Looks like someone made a delicious batch of Fiesta scrambled eggs. Took a lot of forms of energy to make this. Electric, kinetic, potential, chemical, thermal.
Well, they may be very different, but all forms of energy have one thing in common. They have to obey the law.
And we're going to cook it for 1 more minute until the spinach gets wilted.
Now, what types of energy can we expect to find here in the kitchen? For that, let's call in our resident scientist, Dr. Matt.
There are several forms of energy present here. There's potential or stored energy like the calories in food. There's also kinetic energy like mixing or stirring, basically the energy of motion. The heat from the burner demonstrates thermal energy. The sizzling of the peppers is sound energy, also derived from the input of heat. We have electrical energy, electrons moving through a wire to power a blender. And we also have chemical energy released when burning fuels or digesting foods.
So, do you see how many different forms of energy you might find just cooking a meal? Let's see how many you can identify in a little game I call Extreme Energy. Here's how it works. Chef Paula will prepare a simple plate of scrambled eggs. When you hear this sound, yell out the form of energy you think is being displayed. Ready? Begin. How did you do? It's hard to imagine that no energy was created or destroyed during this presentation, but it's true. It was simply transferred from one form to another. That's a lot of different forms of energy to think about. Can we break it down a bit?
Sure. First, there is stored energy, known as potential energy. Each ingredient is made up of molecules, which are atoms held together by bonds. There is energy within these bonds that form the molecules. That energy is just waiting to be released. Until then, it is stored, or potential energy.
So if that's potential energy, what's kinetic energy? Well, kinetic energy is also known as energy of motion. For example, if Chef Paula threw that egg at Dr. Matt,
Wait, what?
the egg would have kinetic energy as it traveled through the air. But once the egg hits Dr. Matt, or the wall, if he was quick enough to duck, and its motion stopped, then based on the conservation of energy, that kinetic energy wouldn't disappear. It would be converted to some other form of energy.
As we begin to eat, let's take another look at potential energy.
Energy can change form in many ways. This ear of sweet corn at rest, for instance, has potential or stored energy. If a tomato should happen to plow into it, some of the potential energy stored in this ear of corn is turned into kinetic energy as it gets knocked over. Another way is when the potential energy stored in the ear of sweet corn gets converted into chemical energy once it's eaten and digested.
Good choice.
This energy gives our muscles the ability to move and do work like moving other things. And since energy cannot be created or destroyed, the rest is given off in other forms, such as heat. Pop quiz! Do you remember what we call this conservation of energy, causing it to transfer from one form to another? Here's a hint. It's the first law of thermodynamics. Okay, that wasn't a hint, it was the actual answer. Dr. Matt, what is the first law of thermodynamics?
The first law of thermodynamics states that energy cannot be created or destroyed. It can only be changed in form. This is also called conservation of energy.
Thanks, Professor. Well, it seems that's all the time we have for today. We now know more than we want to about the first law of thermodynamics, but it's just one ingredient in the science that goes into preparing a meal. Thanks for joining us on The Science of Cooking.
Who knew science could taste so good?